So this question talk about sliding window, and obviously it's nice if we start establishing first. So the spell cast for this is sliding window. Obviously you do argue about using brute force to fight against this sliding window, and for conditions you do come after there's the after conditions and there's the before conditions, which is Leetcode question specific. So coming to this, I just amazed by the beauty of the sliding window. It's like a variable sliding window per se. So I believe that's what they use, and I just find it like a very beautiful form, variable sliding window per se. So last night I did dream, I dreamed about this thing called be like water, my friend, by Bruce Lee. Bruce Lee say that be like water. To me, I think that be like water is just like when a situation call for you to become a state, and you become a state. You become a situation, you become a situation. You become a wallet, you become a wallet. You become water bottle, you become a water bottle. So any situation that it actually call for you, you become the situation. You adapt, and that's what I feel for variable sliding window. Because on opposite side, one is argue that it's called the fixed sliding window. Maybe say you just want 3 boxes to maneuver around your map. Sure, you constantly have these 3 boxes, but for variable, it based on different situation, it adapt. It will change the number of boxes. Sometimes it's 1, sometimes 2, sometimes 3, sometimes 4, and then sometimes back to 1 again. So it keep on changing. But for fixed, you argue is maybe three boxes to maneuver around the map. Variable, you can have 1, 2, 3. You keep on switch around based on the different situation. That's what I feel. That's what I feel for sliding window per se. So yeah. And for this Leetcode question specific, I think that is using this variable sliding window. So we jump in and maybe say we do payout, and let's play out. Right. So now right now we do have A, B, C, A. So at the very start, I mean the core objective, the result that we actually want for this question is to find the result of basically the largest substring. So that's what we try to do. So we play out, first thing first is that we do have the A value, and then sure, and then one of the Leetcode question specific is saying that without repeating character. So this is like the what we call the before condition after sets, right? This is one of the conditions that's been for this Leetcode question specific, is that no sort of like duplicate. So no duplicate. And the first thing that you can think of when you talk about a duplicate, definitely you want to cast a spell of like using assets. Yeah, so we head down, we come down to talk about condition before. So first thing first, sort of like no duplicate. So actually the thing about this when you want to check no duplicate, and then it's checking with the longer substring. When you talk about substring, I think intuitively speaking, you will straight away think of like sliding window, and you are using the property of using the L and the R, and you try to actually maneuver around the map, and then you combine the property of this L and R with the checker for a duplicate checker of the set. It's like usually they work hand in hand. So you you combine the sliding window and the set. What they do is that they will constantly maneuver around the map, and at the same time check for duplicate. They usually work hand in hand, and to me that's a beauty. That's a beauty. You put these two things together, you can maneuver around the map while checking for duplicates. It's like these two property, it just goes hand in hand very well for checking for this type of Leetcode question specific, checking the no duplicate, while at the same time you want to have the condition to be at like the highest number of like elements to be stored in that. So with that, we try to actually play it out now. So obviously no duplicate. So the rule here is very simple. The moment there's duplicate, we got to adjust our readjust our sliding window per se. So this is our current sliding window. Okay. Obviously no duplicate, we can get greedy, so we start to actually do an expansion. So we expand accordingly, and we're still under the rule, so that's fine, right? So we can continuously expand ABC, still fine. And at the same time, when we are doing all this, we have like a box for us to actually store like what is like the max length. And right now we have a free over here because 1 2 3 is free, right? So we come to here, we check, there's like a duplicate, so we can't account for this operation Z per se to actually account to replace the tree that's from before. So we got to start to remove per se, so that's why we do this cross check. BCA is fine, and then this time around we can actually sort of like expand from here, move our sliding window, and now we see a duplicate, and this is not good, and we need to actually remove a value again. So we remove a value, and CAB, it still doesn't replace 3 because 3 is still considered the highest per se. So we come to here, and this time around we have like a duplicate. How we check for duplicate is that if the sort of like we plant, basically we do this operation of like y, throwing our values into this box, and this box is like a set values, right? So say I got 1 2 2 3. Each time there's like a duplicate, it will cancel the duplicate. And what it actually does also check is that it check the length. So if length increase, that means there's no duplicate. And then for vice versa, if so, there is duplicate, right? So that's how we actually constantly check each time we passes through an item. We add in the new element into this sets per se, and then we check for it. So this is the operation Y that's happening. Operation Y, operation Z will always occur each time element is being added or not. So that's how we check, yeah. So because of operation Z, we do know that there's like a duplicate that is going on. So we sort of like remove this value, and then we recheck the operation Z to say that if there's any duplicate or not. Obviously there's no more, so we move on, we come to here, and then there's obviously a duplicate going on. Remove, still have, we need to remove, because sliding window, the thing is that it is contagious. So meaning your sliding window have to move, move from the edges to the edges. So you need to start removing from the edge to the another edge. You can't just remove the one that's the so-called duplicate, right? Because for this case, B is the duplicate, although A is not the duplicate, but it's at the edge of the window. You have to remove it. Okay. So maybe that's also the downside. You have to remove the edge element. So let's call this a W operation per se. Yeah, W operation have to actually occur, right? So you do move to here, you also remove the B, and now you have the C, B, B, and the C, B, B, and you eventually you remove, and then you start with having this one last element. And throughout the entire time, when we were accounting for the largest sliding window per se, we account for the 3. So this 3 is being sent back to the system per se, and I'll call it like the longer substring without repeating patterns. I think the emphasis over here is definitely to talk with like how do we actually tackle this problem specific of having no duplicate and the most number of elements. The first thing that you can think a lot about is like using the combination of both the sliding window and the sets. Using these two, you have the property of like getting the no duplicate checker. You can check for duplicate, and you can maneuver around the map easily with the different number of boxes per se, and get the highest number of like boxes for you to actually check whether it has a duplicate or not. Because you are using the property of like this combining this sliding window and a set. So one definitely do argue that is also that the last thing that you can actually argue is that why not argue that use this brute force way. Yeah. So first and foremost, I argue that sliding window it's smartly maneuvering around the map per se. So you don't have to actually check every single pattern. So if you were to check every single pattern, it will be 1, 2, 3, 4, like this. It's crazy number of like patterns that you are constantly checking. And maybe this time complexity is definitely big O n square as compared to sliding window, which is probably big O of n, because you kind of like maneuver like one sweep across the map, whereas brute force is like you kind of like do every single pattern, which is crazy amount of work in my opinion. And that's my argument for that, for this part per se. Yeah. So yep, everything comes to an end.